Good morning students. Today's topic is prefix codes and weighted tree, which is the continuation of the previous session itself under the module 5 introduction to graph theory. So here the continuation of the previous session itself. Example 6, construct an optimal prefix code for the letters of the word engineering and deduce the code for this particular word. So what we had seen in the previous example itself, similar way we are going to solve, but here the different thing is, here the word is engineering. How many times that single letter is being repeated, those represents the weight. So the given word consists of the letters, so just we'll write the given word. The given word consists of the letter letters. First is E, then En, E comma N, comma G, comma I, and here N is already been done, E is already been done, R, I is done, N is done, and G is done. So E, N, G, I, R with their frequencies. How many frequencies is nothing but how many times they have repeated with frequencies. E is repeated how many times? E is repeated thrice. 1, 2, 3. Check for N. N is repeated again thrice. And check for G. G is repeated twice. And check for I. I is repeated twice. And check for R. R is repeated once. Okay. So respectively, just write respectively. Now we have to arrange. First we arrange these letters in non-decreasing order. These letters in non-decreasing order. Okay, not decreasing order. So write down the frequencies from the non-decreasing order. So which is the least one? R. So just write R. The frequency is 1. Next it is 2, 2. That is G and I. So which comes first? G comes first here in the series. I comes next, right? Both are equal now. Then you check for the series. So G with 2 frequency. I with 2 frequency. Okay, R, G, I, and then R, G, I, then comes E and N. So E comes first, right? Here in the word E comes first with the frequency 3, and then N comes with the frequency 3. So I ordered R as 1, G as 2, I as 2, E as 3, and N as 3. So this is the frequency of all these items. Okay, so this is regarding the frequency. So this is the step 1. Step 1 is nothing but ordering the items in the non-decreasing order. Step 2 is now whichever is the two least. Step 2 would be with the two least frequencies I'm combining and forming a new vertex among themselves. Now here RG. So if you remember the previous problems concept, I'd combine two lower frequencies and then formed a new vertex. So here V1, adding of these are the two lower vertex. Okay, these are the two lower vertex, V1. These two are the lower vertex because their frequency is 1 and 2 when combined. So add these frequencies, it is 3, and the left and right branch. Left would be R with the weight 1 and right would be G with the weight 2. Now this is 3, right? This is the new vertex, that weight is 3, but whatever is less than this 3 should be coming to the left hand side. So which is that? So that is nothing but I will be over here, whose weight is again 2, then 3, right? Then 3. then again 3 is there. I mean v1 is 3, and always e and n is 3 also is there. So what I do is I'll just write here I first, that is with the v2, and these en is already existing, right? This is the new which has been created, so write those e3 as it is and n with the weight 3 as it is, and whatever the new vertex you got with the weight v3, right, that you put it over here. So I is existing 2, en is existing 2. For this I got the new vertex v1 3, that I have put over here. So that is regarding the step 2. Similarly, step 3 will be, step 3 I'll write here itself. Step 3 will be combining in lower 2. This is 3 itself, so combining these two vertex, so that will be v2 now, v2, so their weight will be 5. Weight will be 5, so it should come last after n, after v1. So n will be as it is, right? N will be as it is 3, and v1 will be as it is 3. Okay, and the left branch of the v1 and the right branch, v1 left, right r1 and left g2. Okay, and here when I combine these, I'll get the new vertex, that is v2, and the weight is 2 plus 3 is 5, and the left and right branch would be I and E, whose I's weight is 2 and E's weight is 3. So I got step 3 now. Okay, so now I got v2, v1, v3 main at the same level. I got weights 3, 3, 5. Now again I need to combine these two, so that is step 4. Step 4, when I combine these two, weight will be 6, so v2 will remain as it is. So put v2 is 5, right? Here when you add, it will be 6, so v2 is less, so write first v2 over here. V2 is 5, and their branch is I and E, whose I's weight is 2, E's weight is 3. Combine these two, it would be new vertex. v1, v2 is done. Now v3 with the weight 6. For that, left branch is n, that is 3, and right branch is v1 3, and for that again we have sub branch as r1 and g2. Okay, r1 and g2. Now left out is only these two. Final combination is only these two, that is step 5. Okay, left out is v2 and v3. This should be added, so we'll do it in a new page. So v2, if you see over here, v2 is 5 and v3 is 6. So the new, whatever the vertex you're going to get is a final vertex, right? That I can take it as root. Instead of v4, I can consider it as root because it is a final. We are completing. So v2, v3. 5 plus 6 is 11. So that I can write here. Step 5. So that is root 11. And then we have again v2, v3, same, this branch to the left and this branch to the right. So it is v2 and v3, and within that v2 whatever was there, and within that v3 whatever was there. So within that v2 I had v2 was 5, i.e. v2 was 5, and this was I, and this was E. I think this was 2 and this was 3. This was 2 and this was 3. And here V3 was 6. And within that we had N3 and V1. This was 6. And within this we had N, whose weight was 3. And V1, whose weight was 3. And with this V1 we had two branches again. That is R1 and G2. R1 with the weight 1 and G with the weight 2. So this is the final combination we got. Now we are going to do the off-mind tree. Whatever the tree in the final we'll get. Now this step 6 is to construct optimal tree. To construct optimal tree. Okay, optimal tree. Now this optimal tree will remove all these vertices and the weights, I mean whatever this, and replace with the binary values. So it would be R, that vertex whatever is there, that will be removed. Okay, and then again you have I, whatever that alphabet is there, that you will write E, and then over here it is En, and then over here it is v1, here v3 v1 we are not going to write, and then r, then g, r and g. Put the binary values, left and all will be 0. If it is right branch it will be 1. So this will be 1, this will be 0, this will be 1, this will be 1, this will be 0. Okay, and once you have drawn the optimal tree, from this we are going to get the prefix code from the above tree. The prefix code for I will be 0 0, okay, E will be 0 1, N will be 1 0, R will be 1 1 0, G will be 1 1 1. So this is the prefix code for all the letters, or for all the leaves. So this is regarding the problem number example 6. Okay, next we have example 7. Optimal of prefix code for the following message: road is good. Indicate the code. Similar to previous problem itself, but only thing is we have to consider the space over here. Okay, as well as the letters and how many times they have repeated, their frequencies we need to find. So let us write over here. The given message consists of letter. The given message consists of letters R, O, A, D, I, S, G. Okay, R, O, A, D, I, S, G with frequencies R is repeated once, that is R is 1, and O is repeated thrice, and A is repeated once, and then 2, then 1 1 1. That means R is repeated once, O is repeated thrice, A is repeated once, and D is repeated twice. If you see, D is twice, I is once, and S is 1, and G is also 1. Okay, in addition to that we also have further there is a blank space. Okay, further here there is a blank space, that is in this gap and this gap. Further there is a blank space. So we can represent that blank space in terms of this, okay, in square, something like this, whose frequency is 2. So this is a blank space, so that representation is done like this, whose frequency is 2. So we'll be again writing all these items in the letters and the blank space. Further, this we write in the non-decreasing order. Further, let us write or let us arrange. For let us arrange the letters and blank space in non-decreasing order. Then R, which is lowest one, go in this order itself. R is 1, so write R1. This is step 1. Okay, R is 1. Next, O is repeated how many times? O is repeated thrice, so it will not come over here. Next you see with one series, 1 is R. Next you have, I think, A, so A is 1. Next you have last ISG, all these are in 1. I, S and G, all these are 1. Okay, RAISG is done. Next is left out is with two frequencies, I think it is D, and then we have O with 3. This is for O and this is for D. This is for D. In addition to this, we have blank space. Now 2. When you see D is 2, right? I mean, we have for the frequency D, you can take anyhow. Either you can take D first or blank space first. So since blank space covers before, now when you see this is 1, this is 2, so blank space is already covered before this. I'll consider blank space first, because D first comes here, second comes here, blank space first comes here, second comes here. Okay, and then O is with the frequency 3. Forget, that will be the last itself. So when you choose between D and blank space, since blank space covers already first, I'll consider that as here, that is 2, and then D, and then D with 2, and then O with 3. So this is very important step, how you consider the letters as well as the frequencies of those. So this is the step 1. Next, again repeating the similar what we have solved in the previous problem. So from this step 1, you know, step 2 would be okay, 1 minute. Step 2 would be combination of this and forming one vertex. So lowest is R and A, so we have to find V1. So again, if you find V1, now for example, combination of this V1, whose sum would be 2, and in between R and A will be there. This is 2, right? So where we have to place that V1? At the end after this D. Okay, after this D. So before that, I is G space D, you write it as it is. Write I S G space D, and then write as it is. So I was 1, S was 1, G was 1, and this was 2, and this was 2. Okay, and for this, whatever the after the ISG2, right, the new vertex what was found was V1, that is we wrote as it is till here. Okay, and this combination will get a new vertex, that is V1, that we are going to write over here. So V1 with 2, and that add R with weight 1 and A with weight 1. After this we had space and D is done. After this we had O with the weight 3. Okay, now step 3 would be combination of this. Again you will get V2 2, that should be shifted over here. Okay, combination of these two would give you V2, that is again 2, so that should shift after V1. Okay, that should shift after V1. So what I'll do is I'll write as it is. G you're supposed to write as it is, that is 1. Space you're supposed to write as it is, that is 2. D you're supposed to write as it is, that is 2. Then V1 you're supposed to write as it is. V1 of 2 would give you R1 and A1. Then you're going to write V2. So V2 will give you weight again 2. Okay, V1 is done, V2 will give you again weight 2, so which has the branch I and S whose weight is 1, and then again you have O whose weight is 3. That is step 3. I combine these two, I got vertex 2, sum is 2, so all these again should be put next to whatever 2 weight is there. So I wrote as it is, and then I put 2 over here. Step 4 would be combination of this. Step 4 would be combination of these two vertex, that is 1 2, so that will give 3, right? That will be put over next to O, that is V3. Okay, so write as it is. G and space I have to combine, rest I should write till here as it is, then I should add this. So D you write as it is 2, because these two will be combined. If I see, next combination is these two, so till from here that will give me the weight as 3 and new vertex as V3. Okay, and v3 and 3 with the weight, so that should come last. So till then, from here to here I should write as it is. D I wrote as it is, then v1 with 2, and then again R and A, that would give me 1 and 1, then again v2, that is 2, that would give me the weight I and S with 1 and 1. v1 I wrote, v2 I wrote, O as it is, O with the weight 3, and then I'll combine the new vertex, right, that is v3. So that would give me the weight sum as 3, and the branch would give me g1 and the space as 2. I'll repeat, D I wrote, v1 I wrote, v2 I wrote, O I wrote, then v3 I wrote. This is step 4. Okay, this is step 4. So let me change for the step 5. Step 5 is combination of these again, so it is 4 now. V1, this is 2, this is 2, combination of these two lower weights, so it would be 4. 4 means it will come at the end, so this and this would give me new vertex v4 of the weight 4. So it will come after 1, 2, 3. This you should write as it is. After that, this new vertex will be wrote. So here in the step 5 I'll write v2 as it is. So v2, for v2 I had branch I and S. Okay, I and S. For I the weight was 1, for S the weight was 1, so I wrote v2. After that, at the same level you write O, whose weight is 3. After that, at the same level you write v3, whose weight is 3, and branch was G and space, G and space, and the weight was 1. G and space, and the weight was 1 and 2. After v2, O, v3, the new combination vertex, that is v4, v4 of 4, whose left branch would have D, whose weight is 2. Okay, and whose right branch would have v1, whose weight is 2, and that had separate branches again, R, whose weight is 1, and A, whose weight is 1. So this is the vertex. This is the step 5. Now step 6 will be what? This v2 weight we had as 2, right? Yeah, v2 weight is 2. This and this will be combined, so again it will be 5. So v5 vertex will be created. Okay, these two will be written as it is. So that is step 6. Right, as it is the weight. These two should be combined now. This and this should be combined. So this should be written as it is. So I wrote v3 as it is, whose weight is 3, and who had G and space, whose weight is again 1 and 2. Next I had v4, I'm writing as it is, v4, whose weight is 4, and D, whose weight is 2, and then v1, 2, and then again R1 and A1. Okay, R1 and A1. So that is v4. After that, v4 is 4. This and this combination would give me 5 weight, that is v5, new vertex v5 with the weight 5, whose left branch is v2 itself, whose right branch is O. Okay, so I'll just erase and put it with that side. Since we are getting confused, I'll do it even this. v5 is the new vertex of some of these, so it would give you 5, whose left branch is v2, and that's weight is 2, and whose right branch is O, whose weight is 3. And in that v2 again you have I and S. So v2 is the weight 2, right? v2 is the weight 2, I and S is 1 and 1. Now you got 5, 4, 3. Again this and this should be combined. So that would be step 7. v3 is 3 and 4, so v5 should be written as it is. Okay, this should be written as it is because this would give you the weight 7, right? So v5 with the weight 5 as it is you write. Okay, and that as a branch V2 and O, that is of 3, V2 is of 2, and for that V2 you have I and S, that is 1 and again 1, and then this combined will give me new vertex, that is V6. So here I'll draw it in a red ink. V6 whose sum of weight, V6 whose sum of weight will be 3 and 4, that is 7. V6 and 7, and for that you have V3 and V4. V3 and V4. So V3 is 3, V4 is 4. Okay, and for this V3 we have G and space. And this G is 1 and this space is 2. Okay, for V4 again we have same thing, branch. This branch itself will draw. One is D, one more right, it is V1. For that V1 we have R. For D you write the 2, for R and A. And for this R1 we have 1 and A as 1, and V1 is 2. Final tree is combination of these two trees, that is V7 vertex. Okay, I'll draw it in a new page. Step 8 is the new tree, that is V7. What you're going to do, V7. So combination of V7 will be nothing but final tree. So it is 5 plus 7 will give you 12, but instead of V7, since it's a final tree, I'll write it as a root. So R with the weight 12. So it has two branches. If you see over here, that is one is V5 and one is V6. One is V5, another one is V6. So V5 had the weight 5 and V6 had the weight 7, and within that V5 we had V2 and O. This was O and this was V2. So V2 had 2 and O had the weight 3, and for this V2 again we had I and S. I and S with the weight 1 and 1. So this left branch is completed. If you see, it had actually V2 and O. Within this V2 I and S. Now for this we had V3 V4, and then we had G and space. Okay, V3 V4, and then we had G and space. So at this branch I'll just draw like this, something like V3 at O level itself, right? It should be at O level itself. So V3 and V4. V4 was 4. V3, here I'll just erase. This was O with 3. This is V3. V3 with weight 3. Okay, V3 with weight 3. V3 with weight 3. And for this V3 with 3, again it has two branches at this level. One was G and other one was space. Okay, for G we had the weight 1, and for the space we had the weight 2. Now for V4 again I had D. At this level I had D with weight 2, and one more at the right, its right branch, I had V1 with weight 2, and for this again I had R1 and A1. Okay, so this is the final tree what we got it. Now step 9 would be nothing but doing the optimal tree. So here itself I'll do it in another color. Step 9, same tree, but I'm doing the optimal tree. Optimal tree is, just write the root R. From there, whatever that V1, everything you just skip it off. So V5 is not there, V2 is not there, I is there, so just write I. Okay, just write I. We need to write, they have 8, so there I. And then you have here we had O, just write O. No need to write the weights, just write O. And here again for this we had S. So left branch is completed. Under the right branch you had 1, one section, again second section, again third section, and then fourth section you add A. Okay, and in the first section you took it like this branch, in that you add a vertex. Again in the second level you add G and space, G and space, and under this, after this you add this, right? Here you had D, here you had D, and here you had R. So this is the optimal tree. You got the optimal tree. From this tree, optimal prefix code of all other, that is all these letters we should find. Okay, so let us put the values 0 0 0, this is 1, this is 1, this is 1 1 1 1, this is 1, again this will be 0, this will be 0, and this will be 1. This is 0 1 0 0 because it is left branch, again left branch, right branch. Here again it will be 0, here it will be 0. So for I, start from this I, S, and here it is O, right? Start from I. For I it will be 3 zeros. For S it will be 0 0 1 0 0 1. For O it will be 0 1 1, and G it will be 1 0 0 1 0 0, and for space it will be 1 0 1. Okay, and for D it will be 1 1 0 1 1 0, and for R it will be 1 1 1 1 0, and for A it will be all 4 ones. So finally then you accordingly the code for the message he has told, right? Find the indicate the code he has mentioned, indicate the code. Road is good, for that indicate the code. So for that you should write accordingly the code for the given message. Accordingly the code for the given message is message is nothing. For the given message, road is good. Okay, for the given message, road is good is. For this the code will be, write down there. R is what? R is 1 1 1 0. O is 0 1 0 1, and A is again A is 4 ones. Okay, A is 4 ones, sorry, 1 2 3 4, and D is again 1 1 0. Space will give you code 1 0 1. After road space is there, then I is again followed by 3 zeros. S is again 2 0 1. Again space is there. For space it is 101 101. For this space and this space 101. G again, for G it is 100, and for O it is 0 1. Again O it is 0 1, and for D it is 1 1 0. So this is the final code. This is the final code for the road is good. So this is the optimal prefix tree what we got, and we put the values of binary values and we found the coding values. So this is a very important problem where what you're going to do is important, like letters you're taking and arranging their frequencies accordingly in the increasing order, and whatever the space is there, that is taken as 2. Now what this step how you arrange is very important, that is from the increasing order. If you are ordering in the increasing order, then it's very important. And how you're going to combine those, if you do this step properly, then accordingly vertex 1, whatever that new vertex is there, right, if its weight is 2 also equal to these also, but that should come exactly after these. So if you go on doing that way, then you'll get a proper optimal tree and the proper prefix code. So this is regarding the optimal prefix code. Thank you.